right, so now we're going to talk about geometric sequences. So let's take a look at a couple of examples. All right, so in an arithmetic sequence, you would have to add or subtract to get from one term to another. But what do you notice now in a geometric sequence? Well, if we look at the first one, 2 plus 4 would be 6, but 6 plus 4 would be 10, so it's definitely not an arithmetic sequence. But you notice 2 times 3 is 6, and 6 times 3 is 18, and 18 times 3 is 54. So that is what a geometric sequence is when you're multiplying to get to the next term. 10 times 2 is 20, times 2 is 40, and so forth. 12 times a half is 6, times a half is 3, and so forth. And on the last term, you could multiply by a negative 2, in which case you'll see your signs are going to switch. 4 times negative 2 is negative 8. Negative 8 times negative 2 would be 16, and so forth. So a sequence in which the ratio of any term to the previous term is a constant is what a geometric sequence is defined as. So to get from one term to the next, you're going to multiply by a constant, which we define as r, and it's called the common ratio. So here's an example, 2, 6, 18, 54. We know that a1 is 2, and we know the common ratio is 3 because I have to multiply by 3 to get to the next term. What is the 10th term? So the formula that we'll use would be any term is the first term times whatever that common ratio is, raised to the number of increments we have. So if I have 10 terms, I have 9 differences or 9 ratios. So A10 is the first term, which is 2. The common ratio is 3, raised to the n minus 1, so 10 minus 1 is 9. Put this in your calculator and you'll get 39,366. So you'll see in geometric sequences, the numbers can get big very quickly. So now this one tells you that it's a geometric sequence. It didn't really need to tell you that because you can see because you have to multiply by 3 to get to the next term. And it says find A15. So again, A1 is 3. The common ratio is 3. N minus 1 would be 15 minus 1, which would be 14. Put this in your calculator and you'll get what the 15th term would be. It can also give you an example just by giving you the first term and the common ratio, and it asks you to find A6. Well, if you're trying to find A6, that means there would be 6 terms. The first term is 12, the common ratio is 2/3, n minus 1 therefore would be 5. And you can just put this in your calculator and use your fraction button to leave your answer as a reduced fraction. 2, 8, 32 is a geometric sequence. And it asks you now to find a formula for an. So remember, if you're finding a formula, n will remain as n. So a1 is 2. The common ratio is 4. N minus 1. This is as simplified as this can get because the 4 is raised to a power. I cannot multiply the 2 and the 4 together. So here it says A6 is 20, A8 is 5, and it wants you to find R and A1. Well, first of all, if you remember, AN is A1 times R to the N. So I'm going to use this little piece of the sequence as A1 and A3. So if I go 6, 7, 8, I have 3 terms. So I'm going to use A1, A6 as if it was A1, and I'm going to use A8 as if it was A3. So my last term would be 5. My first term would be 20, and since I have 3 terms, n minus 1 would be 2. Solving this equation, I have r squared equals 1/4, so r is plus or minus 1/2. So I cannot tell whether I am incrementing by a half or negative a half. Now if I want to find a1, I'm going to start with 20. You could just have easily have started with 8. It doesn't really matter. But I'm going to call 20 as my last term. Equals A1. My ratio is plus or minus a half. And since I used A6 as my last term, that means I have n minus 1 would be 5. If I decided to use 5 as my last term, then n minus 1 would simply be 7. Solve this equation for A1. Right? 1/2 raised to the 5th would be plus or minus 1 over 32. Multiply by the reciprocal, and I know that A1 is plus or minus 640. Since I don't know whether my common ratio is plus a half or minus a half, I don't know whether I'm starting with plus 640 or minus 640. If you have any questions, let me know.